Thank you for coming to this talk. My name is Mark Rogers, and I'm a senior software developer with Alfresco. And I'm going to be talking about CIFS in Alfresco 4.0. Now, the good news is that I'm not going to talk about low-level CIFS details. I'm well aware that that could put you to sleep before lunch. And I'm also aware that the next session is lunch, so we'll have a nice prompt finish before we go to lunch. So anyway, that's a bit loud. So anyway, an introduction. I'm going to explain some of the issues we were having with CIFS in previous versions of Alfresco. I'm going to present some of the options for changes. And I'll explain how you configure Alfresco 4. Then we'll have Q&A. Then we will have lunch. So some of the issues So first of all, I'll just give a very quick introduction so that everyone understands what I'm talking about. So this picture here, sorry, it's a bit loud. This picture here shows the relationship between two Alfresco products. There's a product called Alfresco JLAN, which is this blocks here, and that. Sorry, are we okay with the microphone? We have a product called Alfresco JLAN, which provides CIFS, NFS, and FTP protocols. And we also have a separate product called Alfresco, which is the content repository that we're discussing at this conference here. So just wanted to put this picture up. So JLAN is responsible for all the low-level details that go over the wire. The CIFS protocol, the FTP protocol, and Alfresco is a content repository. My talk today is going to be this level here, so it's the Alfresco side. So that's the first thing to say. The second piece of background to this talk, right? Okay, so. So this is a little more detail of what the JLAN component contains. So we have CIFS protocol at the top, and JLAN provides two important pieces. The first is the protocol handler, which is the bit of code that actually communicates over the wire. The other important thing that JLAN has is something called a file state cache. The file state cache contains information that is not in the Alfresco repository. In particular, it has some CIFS is a packet level protocol. It has some things like last modified date. So that's not the last modified date in Alfresco. That's the time that the last packet was written over CIFS. So JLAN provides the protocol and file. The other thing that the JLAN stuff has is locks. I don't particularly want to go into the low-level details of CIFS locks before lunch, because that would definitely put us to sleep. And it's suffice to say it's a little bit complicated. And the other thing that JLAN has is session information. So are you logged in? Who are you? That sort of stuff. So that's JLAN gives us this, and then we've got Alfresco on the bottom that we will talk about. Right. The other issue, the other piece of background information I need to just teach you before I can carry on with the talk, is that when applications store information over CIFS. Because CIFS is not a transactional protocol, applications tend to do what I've called shuffles. I'm not sure it's an official term, but you'll find Alfresco talking about shuffles. So applications like Word won't just open a file, update the file like we'd expect. What it will do is that it will do it basically renames and deletes. So this is just an example. This is a CIFS create shuffle, which is what Microsoft Word will do over CIFS when you try and save a file. So in this example, we start with a file A, and we try and save and update using Word to file A. So the first thing Word will do is that it will create a temporary file. Then it will rename the existing file down into out of the way. Then the next thing it will do is that it renames the temp file back and then deletes the old file. So that's just an example of a very simple CIFS shuffle. But if I didn't explain what a CIFS shuffle was, by the time I got halfway through my presentation, you'd all be confused. So what are the issues that we've had with prior versions? The first is to actually to compare CIFS and Alfresco. So CIFS is a file and folder protocol, whereas Alfresco is to do with content and metadata. So CIFS doesn't really have any idea about metadata, which of course is absolutely crucial for Alfresco. It does have a little bit of metadata like file names and paths, but it certainly won't have any custom types, custom properties, or all the other rich things that we have in Alfresco. It won't have content type. It won't have links to secondary associations. That's a nonsense concept for CIFS. So it's actually quite a big gulf between CIFS and Alfresco. So the first, as I was saying, CIFS does have some hard-coded metadata like title and description. It doesn't have versioning, whereas Alfresco does have versioning. In the example before, in the CIFS shuffle I gave before, it's quite difficult for Alfresco to maintain the version history when the file's been deleted, which is what would have happened then. CIFS is a packet level protocol, which means that I thought this was a particularly daft statement last night, but because they're all protocols are packet level. But what I mean by that is that CIFS, you write lots of little 4K chunks, and each of those 4K chunks appears on a file system. That means that you could have features like, if you're halfway through writing a file over CIFS, you've got half a file. Not terribly useful, which is probably why Microsoft Word use things like this CIFS shuffle. As I was saying, it's not transactional, so the applications do need to work around the fact that their communications could be split in half. Of course, Alfresco is transactional, and you're going to have an entire stream of information going into your repository or nothing. You're never going to have half a stream going into Alfresco, but again, it's a different paradigm. So again, we need to worry about that maps. CIFS is basically create, read, write, delete and rename. There are other operations as well, but those are the main ones. It also has a very sophisticated level of locking that I don't want to go into details, but as I say, it is very sophisticated. Needless to say, it is different to Alfresco. Alfresco, we tend to just have a few. Well, unfortunately, we've got a few different sorts of locks in Alfresco. It is an issue, but we tend to just take a big lock on Alfresco, and then you can't update content. With CIFS, it takes a lock, and then other people can change your content, and then the original person that thought they'd got a lock is informed to say their lock's broken. So it's and there's, sorry, I said I wouldn't talk about it. I started talking about it. What the important thing for the purpose of this conversation is it's different. Alfresco has associations all over the place. Node refs and things like that, they are all important in Alfresco. CIFS couldn't care less. Alfresco, as I was saying, we have coarse transactions, and by that I mean we're either going to have all the content or none. Whereas CIFS, we have lots of little 4K packets that we need to assemble together. So that just gives you a bit of a background for the challenge. So some of the issues that we had in previous versions were first of all, what we tried to do is build a generic way of handling all these shuffles. And what was happening over time is that with each application came along, the code would be hacked to try and cope with that new scenario. And some point, probably a couple of years ago, we got to the point that we'd add a new application and break an old application. And that's a situation that's actually just been getting worse and worse. So that's why we started working on CIFS. So we just had a bit of, as I say, we were having problems building building generic solutions for all the scenarios, and there was a bit of history about you'd fix something and something else would be broken. So automated testing of the CIFS stuff was a bit weak. That's partly because CIFS is difficult to test. So the first issue was automated testing. Second issue that you may have, if you used CIFS in older versions, transaction handling was a little bit strange in, sorry, I don't quite know how to describe it, but the transactions were managed by JLAN in older versions, which could mean in certain circumstances we had so-called leaking transactions. And of course, once you start leaking transactions, it's kind of game over for the Alfresco server. So if you thankfully it didn't happen too often, but we did have cases of transactions leaking, and they would basically mean that you had to reboot your server. So that was an issue. I've already said scenario handling was a big issue, because as we found, as we were going forward, we were fixing stuff and breaking stuff as we were going along. Alfresco clustering was an issue as well. If you could remember on back to the first slide I showed, there's the JLAN has JLAN has session information, it has lock information. That was not clustered, so that was a problem if you're trying to run CIFS in a cluster. And finally, I'll just mention error handling was a little unclear. So if errors happened, you wouldn't necessarily know what had gone wrong with CIFS, and logging as well. It was quite difficult to. JLAN has its own logging, and it was quite difficult to actually understand what was happening. So those are some of the issues that we were attempting to address over the last. It's probably longer than a year now. But the big one was the way we handle all these scenarios and shuffles. So the first thing we did, starting with 3.4, is that we started building out a unit test suite for the piece of code that's involved. Is called the Alfresco content disk driver, which is the bit of Alfresco that is responsible for taking what JLAN's giving and storing the data in the repository. So we started saying on 3.4 we started unit testing. So the idea was to then, whatever we did, we would then ratchet CIFS forward, so we wouldn't regress at any point. So each scenario that we put in has a unit test, and then hopefully it never breaks afterwards. So that was the first thing we did. Second thing was clustering. So there was a number of things. The first was that JLAN, the locks, the update, the session information has been clustered, and the mechanism for doing that is Hazelcast. Not sure it's widely known, but Alfresco itself is moving exclusively to Hazelcast for clustering in 4.2. So that's but the JLAN cluster was the first introduction of Hazelcast into Alfresco, and it worked very well. So all the J groups and EH cache stuff is going. In fact, it's gone from 4.2, and it's all being Hazelcast. So as I was saying, the first piece of work for clustering was to get the file state cache clustered. The other piece of work was to there's quite a lot of information in the file state cache that shouldn't have been cached. In particular, Alfresco is a transactional environment, so it could roll back. JLAN isn't a transactional thing, so stuff could potentially be incorrect. Also, we tended to have paths to node refs being looked up via the file state cache, which, although nice for terms of performance, you can't do that on a transactional system because the data is potentially out of date. So quite a lot of the work was to just work out what should have been cached in JLAN and use and cache that. And at the point that the dependency upon the file state cache, then, for example, FTP would work cluster. There's still possibly a few issues, but at that point, FTP would work clustered because it's a fairly simple protocol, and there weren't really any dependencies on things like the CIFS locks. So And also it's worth mentioning that there's a piece of code that's required by CIFS called the node monitor. And the job of the node monitor is to see when files change by other ways in Alfresco and tell CIFS in particular about it. So the typical case is if you delete a file via WebDAV or share or something like that, then CIFS needs to know. It may need to do something wacky with its locks, or it may just need to delete stuff out of its file state cache. So there's a piece of code called the node monitor. So anyway, I'll just mention that that's been fixed, because it wasn't terribly. I think it assumed that there'd only be a maximum of 2 nodes being updated per transaction, which is not the case. So clustering had some work on it. I've also mentioned about the transaction boundary. So the transaction boundary moves down to Alfresco. So for each CIFS operation, there will be a begin. The CIFS operation will finish, and there will be an end. And all dependency on the transactional data, all transactional data has been removed from the file state cache, so we don't cache stuff that we shouldn't. It's just worth saying that. So error handling has been reworked. So you'll find, hopefully you'll find when things, well, hopefully things won't go wrong, but if they do, hopefully you'll find that the error handling is clearer. And also with these issues, I'll just mention that you can now use the normal sort of ways of logging. So the log4j on the disk driver stuff to find out what's going on, I mean, you can still turn the JLAN logging on, but it's no longer the only way to do it. So bog standard Alfresco log4j will actually give you help in what's going on. So as I was mentioning, the big issue that we were struggling with was how to deal with shuffles. So we've put a new framework for dealing with the shuffle scenarios. So that's what I'll be showing for the rest of the presentation. So and we didn't want any of this hard-coded shuffle logic because, as I said in the beginning, we were finding that hard-coded shuffle logic was just basically it was beyond the point that it was maintainable, and excuse me. We basically, as I was saying, I'm okay at the moment, thank you. We found that we'd fix one scenario and break another. So all that hard-coded shuffle logic has come out, and hopefully it is now simple enough to understand. And we also had to worry about where we'd store state. So in particular, I mentioned if we start storing data too low down in the stack, then if a transaction rolls back, we have to worry about rolling that, or if it completes, we have to. So anyway, we moved all that state information out. So that's the shuffle engine, and I'll show it later. So I've mentioned the create shuffle at the beginning, when we have a file and it's shuffled with a temp file and an old file. So that's what I'm talking about with a shuffle. So we designed 2 possible approaches. And the first The first approach for dealing with shuffle was the so-called sausage machine. That the idea about the sausage machine is that that CIFS would issue its creates, deletes, updates, and we'd put them in a pipeline, and then we'd look at that pipeline, and when we'd resolved what should have happened, we'd basically update the repo. So does that make sense? So it would be basically a sausage machine where we throw all the CIFS commands in one end, turn the handle, and get the repo update out of the sausage machine. So that was the first thing we had. However, it's worth saying it did work. So step back. So there's two approaches. One was a pipeline, and the other was we might need to call this something different, but it was basically the idea that we'd have a number of scenarios watching what was going on over the CIFS protocol, and they would butt in and do stuff as and when they recognised content that they were interested in. So the sausage machine, it does work. However, it became apparent as we got further that the big one was actually if you're loading commands into a pipeline but not committing to the repo, and then your repo's shut down, you've lost your data. So at that point, that's a bit of a showstopper. But there was also complexity, like saying a simple operation like does file A exist. If you've got a delete in your pipeline because your scenario hasn't yet decided whether it should delete that file, then you need to go through, as well as looking on the file system, you also need to go through your pipeline, and it all became a little bit complicated. So unfortunately the sausage machine didn't work. Well, saying it worked, but it had those two issues. The second scenario, the second way of making it work was what I've called the watchers, and this is what actually got implemented. So this was the second attempt. So CIFS commands go through a set of scenarios, and they basically say what should happen to the repo, and those scenarios compete. And at the moment, we've got a very simple, a very simple way of ranking scenarios: so high, medium, and low. Basically, the highest scenario wins. So that's a very simple approach. It may well become more complicated in future, and in fact, in the last month or so, I had to implement the first scenarios that cooperate. So, saying this is very much work in progress, but this is what we did for 4.0. So the scenarios contain their own state. So and many scenarios can run at once. So that's the idea between. And this has the benefit that at the end of each command, Alfresco is in a known persistent state. So if the server was then shut down, you wouldn't lose data. Might not be quite what you expect, but you're not going to lose data. And the idea behind the scenarios is that they it's kind of, you know, like you like when you're working on a cache system, you can't just delete stuff. You have to counter transact and then that actually works with our versioning. So you can see what's happened. So anyway, that's the idea. So if we go back to our create shuffle, the file exists. We create the temp file. Actually, what happens is that temp file has a certain name pattern. So I can actually show you what the pattern is, but if it's Word 2003, it's sort of 8 digits and a .tmp. So the temp file comes along and a scenario gets created to say I could be interested in this. It could be a Word. It could be a Word file. So, and the next thing is that this is the same create shuffle. So this is actually the most complicated slide in my presentation. So the next part in the create shuffle was to rename file A out of the way, but at this point our Word scenario fires, and instead of renaming this file to here, what it does is, first of all, it copies just the content. And if you remember, CIFS is only interested in content. It's not interested in metadata or file refs. So we copy just the content from the temp file into file A. And instead of renaming this file down here, what we do is we rename that file down there. So this is just sleight of hand. And then we put file A, instead of being down here, we put file A over here. And we do that as one transaction. So now the next thing, hopefully, CIFS is going, the word shuffle is going to move the temp file back to where we had. So at that point, we've got file A with our new content, and its node ref's the same, all its secondary links are the same. And then the final bit is that what was the temporary file is deleted, so we've got file A. So that just explains kind of how the word create shuffle works. And over time we get a collection of different patterns. So we've got a create shuffle, which is triggered by a file being created with a funny name. You can have there's a rename shuffle, which is again a file being renamed to a funny pattern. So that particular one is used, for example, I don't know if anyone's old enough to remember the editor VI. When you edit a file in VI, it copies the file to a file with tilde at the end, creates a new file in its place. So that's the rename. And we've got another few scenarios. Interesting ones are open file. So open file is just dealing with files being opened and closed, but it's got a counter for how many opens and how many closes. And so if you open a file twice, close it once, then the file's still open. If you open the file twice, close it twice, then it actually gets closed on the second. So the open file scenario is doing that opening and closing, and the final scenario that's worth mentioning is the non-buffered. If you remember, I said each scenario has a priority. The simple non-buffered is the lowest priority, and that basically says if no other scenario does anything, I'll do the simple and stupid thing. So a create would be a create, an update would be an update, a delete would be a delete. So that way, for every operational command coming in, the repo will be updated. We don't quite, according to which scenarios we fire, that the repo may be updated in different ways. But at the end of each command, the repo will be in some known state that is persisted, and over time, I'm quite sure we'll get other scenarios. And in fact, since I wrote this presentation, we've got one more scenario, and it's worth saying that this is a configurable framework. So although we've worked with the obvious things like Word and Excel and PowerPoint and VI and text edit and other applications like that, it could be that that your organisation's using some other application and that's doing some other shuffle. So you may find that these scenarios actually work with the first thing when you have some application that's having problems with Alfresco CIFS is to either use the log4j output to see what's happening, or possibly do a Wireshark capture and just try and work out how the shuffle is working. Then you may be able to configure one of these existing scenarios, and I'll show in a bit how to, well, assuming I've got enough time, I'll just show. Right, I've possibly got enough time. So you may be able, hopefully you'll be able to configure one of these out-of-the-box scenarios, or you may actually write your own. They're not that complicated. So, this is these are the important classes that you might like to look at. So we've got JLAN at the top, which is, as far as I'm concerned, is a black, and this talk is concerned, it's a black box. The first class that's worth looking at and debugging is called the buffered content disk driver. The buffered content disk driver has, as its name implies, it has some fairly light buffering, just to stop you having to get the same content over and over again. Theoretically, it would work. Alfresco will work without that buffering, but it's there. The important class to look at is the non-transactional disk driver, because that's where the rules get brought in. So the rules have a number of scenarios configured for them, and then from the non-transactional disk driver, that either comes through a class called the file system command executor down to the cunningly named content disk driver number 2, or some commands basically just go straight down. They don't bother with all the shenanigans. In particular, I didn't want the read and writes to have to go through all the scenarios, because that would have potentially murdered performance. And when it comes down to it, shuffles are all about renames, rename, create, and delete. So really those 3 commands. Open needs to be in there as well, because of the need to do the reference counting. But so the rules tend to work on open, close, rename, whatever. Right, I've got 5 minutes, so I will just show you the configuration, and and then perhaps if people are interested, they can talk to me afterwards. So, so the important file is the network protocol context that contains, if you remember a couple of slides ago we had the scenarios. So there's a, in there you'll find there's a property called scenarios, and this contains the various scenarios that CIFS is configured with. So, for example, there's one, create shuffle for Excel 2003, and that's first of all, it's a scenario create shuffle, and it's looking for files, and this is just the pattern that Excel 2003 looks for. So it's looking for 8 characters 0 to 9 A to F, and then at the end of the string. So if a file is created with this pattern, then a create shuffle will work. Here we've got a create shuffle for Word 2003. So if a file is created with ending with the pattern ~wrd dot something dot tmp, then a create shuffle starts for potentially for Word 2003. There are more scenarios, but that's what fitted on the page. And if you have to build your own, scenario, then it's not too difficult. We've got this scenario instance. So the create shuffle was looking for, if you remember, the create shuffle was looking for files being created with a certain name. So all the create instance has to do is return an instance, and it's given some context, so we can store we can store a bit of state in there. So what are we doing? And our operation is whether it's a create, and it's got the parameters from CIFS in there. So if it's a create, what's the name of the file being created? So that's scenario instance, and the other important interface is cunningly called scenario instance. Fairly simple. Ranking is the high, medium, and low. Evaluate is the important thing, because scenarios have to evaluate the operation, and they can return commands. I've used operations are the things that JLAN is telling us to do, and commands are the things we're telling to the repo to do. It's just, I mean, fairly synonymous, but that's the naming I've used. And the final thing is the scenario complete. So a scenario can be complete either because it's done something or it's worked out it's irrelevant. So that's a scenario. I have a feeling I'm out of time, so I should ask questions because I don't want to delay you for lunch. Please continue. Thank you very much for saying that. I'll just take this question and I'll continue.
When new scenarios are added, will we be informed in any way?
I could do. I hadn't thought about that
maybe,
at all.
Maybe AutoCAD drawings. AutoCAD drawings may not follow the word creation shuffle, so we don't know
possible.
what they do.
We don't, but that's a good example. So in that example, if we're using AutoCAD as an application, that's not an application that I've used. So we might find that AutoCAD saves its WG files, that much I know, or DWG files. We may find that that AutoCAD either uses one of the existing shuffles, and it's possible because if you think about it, there are only so many combinations of create delete, rename to or we may find that it does something really wacky.
They do DWL for own locking techniques. They do BAK for back files. They do temp for whatever.
The first thing is to do the Wireshark, so we can actually figure out what it's doing. Normally when we add a scenario, there'll be a gyro issue for it. So do the Wireshark, so we need to do some analysis. So I know your question was how you get notified. How you get notified is normally gyro, although, dare I say it, I could do a blog post and figure out how to do that. I could do release notes, yeah. I could do release notes, but yeah, so for AutoCAD, if you were to raise a gyro with with Wireshark, then that might be nice and easy to do. Or even better, you might be able to figure this out and do it for everyone. Sorry, I think I'm out of time. So I'll carry on into lunch. I will be quick. So finally, I just wanted to give a quick example. And this is a rename shuffle, which is something that VI, for example, does. So we start with file A, and it renames it to file A with a tilde at the end. Then it creates a new file in its place, and then would move the file. So for this example, we've got the rename shuffle. The scenario fires, and instead of that delete a file, excuse me, instead of that delete a file A, it copies the content, it deletes the new file, and it moves the tilde file back. So that's the rename, and I will just, so I just wanted to show code. So this is the rename shuffle. So the rename shuffle is basically just looking for a file being renamed. Yeah. So the rename shuffle is a scenario, and it's looking for a rename file operation. And if we match the pattern, then we return a new instance of the scenario, else we return null. So I just wanted to give an easy example and show it's not terrible, it's not terribly difficult. So that's the rename shuffle. And the scenario instance was looking for, well, first of all, so the scenario instance gets created with a first rename. So when the first rename comes in, it basically just remembers what the file, it remembers the file name that it was from and the file name that it was to. Then it starts, the way I've built these things, they tend to be a big switch statement. Then it goes down here and it starts looking for a create. If I go up, so I'm jumping about a bit, if the scenario takes too long, then we just, right, this scenario is not timing out, but we could time out there if we wanted to. So we basically then look for, first of all we look for a create, then we look for a delete. If we get the delete, then we basically fiddle around, inject our commands, and scenario is complete, and return a compound. We can either return a command or a compound command. Command is a signal one, compound command is a list of them. So, unfortunately, I've run out of time, but I will. I'll be here to ask questions, or I'm online anyway. So, thank you for your time, and hopefully, this is. It's probably worth saying that this came in 4.0. The shuffle stuff has been fairly stable, apart from some issues with Apple. Apple rewrote the CIFS drivers for Apple Lion and caused chaos for every CIFS provider. It looks like they've rewritten them for Mountain Lion as well, so but that shouldn't be so much of an issue. But since we put this together.
Is just a short question. Anything new coming in
4.2, we've got better Lion support, so Mac Lion support. In particular, there's a couple of issues with Finder for Lion, so those are brand new in 4.2, and we'll probably do something with Mountain Lion because that's on the list. Saying that Windows seems, and perhaps Windows 8 will change, but we don't know. I haven't used Windows 8, but okay, thank you.